Hello and welcome to another edition of the Radio Mechanic. I'm going to take a look at this Emerson set that I picked up at the flea market a couple of weeks ago. And we haven't stopped working on the 916. In fact, we'll take a look at this little video clip here. Okay, so now you're updated as to what's going on with that. But I wanted to get started on these sets. They've got some unique design features. In fact, I'm thinking of making a video, Nerd's Corner video, on comparing the different design philosophies between this Emerson and the Silvertone that I picked up at the same flea market I got this at. And as I had mentioned, or as I'll mention, I've been shooting various little clips. I've pulled the plastic strips out here. One of them was broken, but I think I can fix that with no problem at all. Pretty sure I can recreate this dial. Now this originally, I don't even have a pencil in here. Shame on me. Originally, pretty pink as Big Clive would say. Originally there was these lines that are just visible here, came in and then they went down and made an arc and then continued out the other side. We have the Emerson radio and television with the G clef or the treble clef depending on where you grew up. Right now, all that's left of the dial markings are the wavelength markings, 3000 to 1600 or 1600 to 3000, depending how you look at it. There's another ring inside of here that you can see under high magnification. There's no way the camera will ever see it, but it has the actual frequencies marked in there. I didn't think they were on here at all, but I put it under magnification, and sure enough, the frequencies were originally marked in an arc in here as well. But I wanted to get a jump on this and see what I was dealing with. Make sure that it was going to be a viable radio to repair. We'll take these two little levers, pop these knobs off. These knobs, pretty corroded in here, and I had them off, did some cleaning, and actually put a drop of oil on them, and they're still a bear to get back. But these little levers make short work of it. Well, I want to pop this thing out, take a good look at the speaker, see what I'm up against. I've got various parts on order. I've tested the tubes in both this and in the Silvertone. Nice wooden knobs. I love these old wooden knobs. I'm going to put these right in the jar so they don't get lost. A lot of the tubes in the Silvertone are bad, which is unusual. Usually I find the tubes are, it usually isn't more than one. But the Silvertone, I think, had a lot of hours on it. And most of the tubes are either extremely weak or have heater cathode leakage. Let's see here. Take a small screwdriver. Oh, this one still got the screw in it. Usually that's missing. That's unusual to see. Oh, what am I doing? I just said it had the screw in it. Usually they're missing. It's very rare to find the screw holding that connector in still there. And we'll just work this out gently. Wiggle it back and forth and bring it on up and out. There we go. The wires appear to be in good shape, not cracked. They're still good and flexible. Usually the cotton covering on these is rotted away and the rubber inside's a little brittle, but these appear to be in good condition. We've got our original antenna and ground wires, I believe. Now, you can see how rotting or rotten. Well, actually, yeah, they're not that bad. It was just that other piece. They're actually still intact. Here's what really annoys me, and I mentioned this in another video clip about this radio as well. Screws are missing. And these are not easy ones to replace. These are unique screws with the washer built into the head. I'm going to have to see if I can track some of these down. Now, if I still had access to the machine shop, if I was still employed or still working, wasn't retired, I'd take some big pan heads or cheese head screws and go into the machine shop and just run them in the lathe and put, cut away enough of the head to make the flange. But I'll have to see if I can find some of these somewhere. Why people don't put screws back in is just beyond me. I mean, what's so hard about just threading the screws back in after you've had the thing out? It's very rare to find all the screws. Alright, tip this thing back up. Slide it out of here. Let's see what this looks like underneath. That might be the original filter. That's what I was hoping I'd see, a real simple piece, and it's held in with screws. I should be able to recreate that fairly simply. Take a look underneath this. Freddy's Radio Servicing, Kensington, Connecticut, 58 Harding Street. He's probably no longer in business. Nice layer of rust on the transformer. The tuning caps are fairly clean. Oh dear. Okay, that appears to be a replacement filter cap, so that one that's up on the top is probably disconnected. Let's see if we can look down in. Yep, all the wires have been cut off of it, so it's been replaced at some point. And that capacitor is, does it have a date on it? 27 microfarads. It's a Mallory. I think we can pretty much rest assured that's gone. Some big dog bone style wire wounds. This resistor on the back has gone open evidently. This is a fairly common failure on these sets. These resistors that are riveted to the back of the chassis go open, and somebody's replaced those at some point in time. That looks like an early diode. Let me glance at the schematic here. Someplace in here we've got some gimmick caps. I've got to be careful not to destroy those. And I did a video on gimmick capacitors before. A lot of times it's just two pieces of wire twisted together. Sometimes they'll take a lead and wrap a wire around it. The wire will come in from the side and wrap around it. Sometimes they wrap it around a resistor. It's open on one end. It's just a small bit of capacitance to neutralize the circuit so there's no motor boating or oscillation. This set, the volume control is an antenna control. It short circuits the antenna. I'll go into that more in depth when I do the Nerd's Corner video. But the volume control in this is not in the audio circuit. It merely shunts out the antenna, much like a TRF set would do. That almost looks like a new replacement. No, I don't know. I guess the enamel's the same color. Probably not. Aerovox high farad. 8 microfarad, 450 volts. 8 microfarad, 450 volts. I think we can be pretty sure those are dead. As will be all these waxy caps in here. I suppose we can take a quick look at the electrolytics, but I think I'll find they're dead. I certainly... Oh, here's a gotcha. Here's a gotcha. Get up. Whoop. Bang into the camera. This is why I say do not turn these old radios on. Do not plug them in. Let me see, make sure we're in the frame here. Where's my... Yep. You see this capacitor right here? Well, here's your B plus bus or high voltage or whatever you want to call it, DC bus coming in, going through the audio transformer to the anode of the output tube. You turn this thing on and that cap is leaking badly or shorted, kiss your output transformer goodbye. And even with your dim bulb setup, that can be burned up very easily. It's not designed to carry any real current except for what's going through the anode. If that's a dead short, before you know it, your output transformer's finished. We also don't want to lose our speaker field coil. So in fact, I'll check that to make sure it has continuity. But if this if this output capacitor on the output of the Pi network here is shorted, if this one's shorted, all you lose is the rectifier tube, possibly the power transformer. But if this one's shorted, you can burn out the field coil. That's why you don't turn these things on. You just don't plug them in. I just want to see if it works. Poof, too late, you've destroyed parts. We're going to make some checks. We're going to check the capacitors. We got 8 microfarad, 6 microfarad. It's probably these here. I don't know what the big one is for. I haven't found it yet. 12 microfarad, maybe it's this one here. Yeah, that probably is that one. It's probably the bypass capacitor. It's a monster. Yeah, 12 microfarad. So that's probably that one. And we do, of course, want to make sure that this 0.03 isn't shorted so that we're not dumping DC directly into this grid on the number 42 tube. Good way to burn up a number 42. So I'm gonna make some basic checks and we'll see what I find. Oh, that's great. I thought I was recording. I wasn't. Okay, just to make life easy. I thought I'd walk you right through this. It appears the field coil, primary and secondary of the output transformer are intact. So that's a good spot, good start. And I don't know whether or not, yeah, it was recording. The voice coil is rubbing seriously. I can actually see it off center. But the spider is adjustable. I can loosen the nuts and bolts holding the spider, recenter the coil, tighten the spider down. It should save that speaker once I fix the tear in it. I'm going to set up to test some caps here real quick. Okay, we've seen this in a previous video. My little test setup. The lamp is good. All this is going to do is inject DC into the capacitor through a light bulb. When I go to the test position, we should see if the cap is viable, we'll see a charge cycle, and when I flip it the other way, we should see a discharge cycle, and we see nothing. So that cap is basically open, absolutely nothing. So that 8 microfarad cap, while not shorted, is absolutely open. And let's see where the other lead heads off to. I'm sure the other one's in the same condition. Down here. Right to there. Come on, get on it. There we go. Absolutely open. No life whatsoever. And I think the big cap's going to be grounded. The big cap goes directly to ground. Again, it's coming out here. And it looks like that one's shorted. Unless there's another path to ground. Maybe there, if that's the cathode resistor, there's probably, yeah, that's the cathode resistor. I do believe. There's more light down in there. Okay, so that's got to be pulled out of there. So it looks like I'm going to have to go in here and just shotgun this thing. I was hoping I should take some more checks here before we do that. Make sure the output or the power transformer is okay. We've got nothing but a dead short here. Let's chop this thing out of here. Where are my cutters? Chop that off there. This one off here. Done. Let's see if the power switch is any good. Go back to ohms. And I think the fans of the 10-buck test bench will be happy that I'm out here working at the 10-buck test bench. We haven't done this in a while. So, well, okay, we got meter deflection. Going to the switch. Okay, we have continuity there anyway. Now what I should do probably at this point is pull the rectifier tube and put this thing on dim bulb. Nice looking 80. Put this thing on dim bulb and make sure that the primary of the transformer isn't short circuit, or the secondary even isn't short circuit. So we'll take a look at that real quick. Move that out of the way. I'm going to get a line cord and rig up some test clips, and we'll check the primary of this transformer. Let me get some stuff set up. Okay, I don't think the dim bulb is in frame, but if I put it in frame you won't be able to see this. I put it up there on the wall without making any test shots with the camera. But it's up there where it won't be blocked by any equipment on the top shelf of the bench here, so I guess it's going to have to live there. You'll have to trust me. Do we have trust? I hope we have trust.
Trust me.
Take that off of ohms. I've got my power cord set up here, and turn the variac down, flip it on. We're on dim bulb, 1 amp. Plug this into the isolated variable. There we go. We should be ready to rock and roll. We'll start turning up the voltage. Oh, turn it on, dummy. I don't see any current draw on the meter. There's a little bit. We've got 44 volts, 100 milliamperes. Seems reasonable. 90, 100. No activity on the dim bulb. Well, that's 200 milliamperes. That's kind of, oh, we got tube filaments. Okay. So tube filaments should be lighting up. Yes, they are. The tube filaments are lighting up. Pilot lamp is lit. So, it appears we have a viable power transformer. That's good news. We even have a good dial lamp, which is unusual. Ah, did I just get tingled? That's isolated. I shouldn't have got tingled. No, I guess I just caught a hair. Felt like I got a bite, but I think I got a hair caught in the edge of the desk here. Yeah, there's nothing there. Absolutely fine. Alrighty, so we're going to shut this down. Oh, I probably did get a tingle. Let it cross the line. No, it's isolated. I'm on an isolation transformer. Yeah, there's an across the line cap that I should cut out of there, but it doesn't appear to be leaking too badly from the current draw. So we know power transformer's okay. Apparently audio output transformer's alright. Field coil's okay. Got my fingers crossed on the voice coil. Let's see, we'll shut this off. Make everything cold so we don't have any accidents. Disconnect this. Now I'm just going to proceed with well, I'll take some resistance checks. This antenna coil looks fine. Yeah, I think that antenna coil is fine. I got a feeling this radio might work once this couple caps have been changed. So rather than bore you with that, you've seen me change capacitors 100 times. We know these are completely gone. We know most likely this one is as well. That cathode bypass. What a monster for the cathode bypass. We'll go in here, change some suspect components, and I'll be back when I've done that. Good grief, I did it again. Chattering away, camera's not on. This is that supposedly 12 microfarad cathode bypass capacitor, and this one's supposedly rated for 225 volts. You can see the test light is on. It's been on for several minutes now. It started out at 100 volts drawing, 45 to 50 milliamperes. We've dropped down now to about 30 milliamperes of current. The cap is still drawing after 10 minutes. Oh, and it's starting to get a little warm on the back. It's basically a big resistor. But that's why you want to check this stuff. Now, this wouldn't have done any damage, being a cathode bypass resistor, but the audio would have been horrifically distorted because there wouldn't have been any cathode bias. It was basically a short to ground. It's taking this thing, and it'll only be operating at a couple of volts. So these will do just fine. This is a 10 and a 2, totals up to 12, and they're rated at 50 volts for cathode bypass service. That's absolutely fine. 10 volts would do the trick there. But this is what I had, so that's what's going in to replace this thing. As I'm working on the chassis, picking away at it, I'm intermittently going back to the speaker, and I've been stitching the paper back together with little drops of rubber adhesive. Whatever happened to this thing was fairly traumatic. Whatever punched a hole through the grill cloth, tore into the speaker, but I found 90% of the paper is still here. It was crumpled up. You can see all the wrinkles in it, and it was hiding behind the cone here. It all got shoved back behind it. So I'm pulling it out a little at a time, and I'm stitching it back together with rubber cement. And I think when I'm done, I'm only going to end up with a little tiny 1/4 inch diameter piece missing here, is what it looks like. I think 99 or 90% of it, not 99, 90% of it's here. And then I'll just have to cover this. I haven't covered up the magnet yet because I want to recenter the voice coil with the spider. The only thing that's giving me concern is there's a lot of wrinkles over here that look like they might be moisture damage. I'm hoping the voice coil is still coaxial to the center magnet piece. In other words, I'm hoping it hasn't tilted off to the side so that, you know, you might be able to center up the top but the bottom's still rubbing. I've got my fingers crossed. I'm hoping that I can center this up and save this cone. We'll see, but what I'm doing, like I said, in the meantime, is I work on the radio chassis, then I come back here and I stitch a little bit together, let that dry, and I'm slowly pulling this back into position and see if we can repair the cone. Okay, I'm down to what I thought was the last 3 capacitors to change, and I got to looking at things, and this radio proceeded to kick my butt. I could not for the life of me figure out what was going on here. One thing led to another. I'll try to take you through it as I found it. I'm looking at what I thought was a capacitor, and it turns out it is, but it's actually 2 capacitors with a center ground. And then I spotted this insulated wire running from one end of the capacitor to the other. And I'm like, what the hell? And there's also this resistor. Now, I initially saw one of these and I thought, early diode it looked like, but no, this is a resistor. It's got a pointed end on it, and you read this would be orange, black, red. I'm looking at this thing going, what's this wire for? And then I looked at the schematic, and this time I'll try to keep everything in frame so we can see what's going on here. And let's see, am I in frame? Yes. We come off the cathode, we have a 0.02, then we're supposed to have a 300 ohm resistor, then we're supposed to go to a 4500 ohm resistor to ground, and the one that's in there is a 3000. It's a 3K instead of a 4500. And then we have another 0.02. So I measured across this capacitor, or this, where this wire was, and it's in the mega ohms. So I think this is a 300 ohm resistor. I clipped the lead, and this is basically open. So I think that's an open resistor, a resistor that's gone bad. Get some more light in here. This value is, well, this resistor is off the scale high. And this capacitor, I can put an ohm meter from one end to the other and I can see leakage. That's where most of my reading was coming from. After I cut this out, this was doing nothing. It's basically open. So I've got 2 capacitors, a resistor that's open, and this resistor here. And again, if we look at this, we've got capacitor, resistor across the 2, second capacitor, and the 3K one to ground right here. So that wasn't too bad. And I got this out of my way so I could work in there, and I thought for all the world, I said, well, that's my first impression was that must be this trap. It isn't. That coil is this coil right here. Switches in and out for shortwave or broadcast band. But then this caught my eye, and I said, this looks like regeneration. It's coming out of the anode, it's feeding back into the screen grid. Alright, I'm filming this or videoing this at a later time because I made such a dog's breakfast out of trying to explain this circuit. that I said the only way this is going to make any sense is if I take a couple of good deep breaths and come back and try again. As I mentioned earlier, our volume control here is not in the audio circuit. It is basically shunting the antenna to ground to reduce the signal level. It might be slightly varying the cathode bias over here on the IF tube, but it primarily shunts the antenna to ground. That's primarily what it does. It has almost no effect on the cathode over here. I've done some measurements. But I'm looking at this thing, and the coil I just showed you is right here. And here's your shortwave, AM shortwave switch. So in my head, this is the oscillator. This is where I went, you know. This is the oscillator. We're doing our mixing, we're doing our converting, producing our IF, and it's, you know, going down through. Okay, as I was saying before the camera battery died again, I'm going to give you a warning. Don't buy one of these Canons, the Pro Shot, or what do you call them, Power Shot SX70. It's got the worst battery life I've ever seen. My other Canon, the SX20, those AA's would go forever. This thing just died with no warning. It showed no warning, battery warning. It just shut up and quit working. As I was saying, I had convinced myself that I was looking at the oscillator section here, because like most sets, let me find I've got another schematic here to look at. Most sets, you have a pentagrid converter in the front end, and that does your conversion. I've got some blown up pictures here, be easier to follow. Oh, I'm so well prepared as usual. Just amazing how well I do with this, isn't it? I don't have the blown up one for that. That's alright. This will work. Usually our converter looks like this. And what we have, you have this double grid here with B plus on it. That's the anode for the oscillator. So you've got your tune circuit here. You've got your cathode going into the tune circuit. You've got the feedback coming back in, going to the grid. And this pair of grids here becomes the anode for the oscillator. And your off-the-air signal goes to a grid that's between these two and mixes. It does the mixing and conversion here, and you get your IF out, heading out that direction. That's called a pentagrid or 5-grid converter. 1, 2, 3, 4, 5 grids inside that. Well, because I've seen it, you know, we've all seen that so often all the time, my head just automatically went to where this is doing the same thing, because got a couple of coils here, you know, and I just, at first glance, I said, here's my oscillator section. That's not what's going on here. Not at all. Because the next thing I spotted was this configuration here, down here. And I looked at this coming out of the anode, coming down through here, feeding back up into this grid, and I said, this thing's got super regeneration. This is a regeneration setup. Now somebody out there is going to say, well, of course, on oscillators, regeneration. Well, yes, of course it is. But it's in the second stage of the tube here. This is the oscillator. This is not the oscillator in this circuit. This is feeding back into this grid, and this is what's doing the oscillation. It's also doing the regeneration. This is amplifying via regeneration while it's doing the mixing and converting. This stage is just a gain stage running all the time, pumping signal into here to mix with the oscillator, and they're controlling it with this potentiometer by shunting the antenna to ground. This is just running at a very high gain all the time. But what threw me, I kept trying to find this transformer or this pair of coils, and I could not find them in the radio. I found this one, I found this one, I found these two, I found these gimmicks. I couldn't find this anywhere, and I was losing my mind, because I looked at the IF transformer, and like every IF transformer, there's 4 leads coming out the bottom, and I said there's not enough wires in there to make this, you know, to have this inside there, until I sat here and studied it for a while, and light dawned over Marblehead. My 5th wire came out the top to my next 6D6. It's got a grid cap, so that goes in the top of the IF transformer can. Coming out the bottom, there's only 4 wires, and if you look at this long enough, stare at this long enough, you realize that's all it's needed. This dashed line kind of represents what's inside the IF can. Here's wire number 1, that's going to the grid. Wire number 2 here, the B plus, is coming in here. We'll call this wire 2. Wire 1, call this wire 2, going through the IF. This is all internal. This stays inside. Here's wire number 3. That's feeding our anode. Now we've got a ground over here and a ground over here. This, for all the world, it looks like this is next door to that. It isn't. This wire, this is internal, or excuse me, this is internal. This is internally connected to the bottom of this coil, and this single conductor comes out and goes to ground. So 1, 2, 3, 4 wires going into that can, and you have both the IF transformer and this feedback transformer. See, once again, this ground and this ground are tied together. So we have 1, 2, 3, 4 wires exiting because the ground is connected. It took me probably 2 hours of farting around and trying to trace all of this out in the wiring until I could figure out what the hell was going on. But I kept going back to, this looks like regeneration, and I couldn't figure out, you know, I'd never seen a superhet with regeneration before. So I went back to Elements of Radio and searched through here, couldn't find anything. And then I pulled out my Radiotron Designer's Handbook. And this, by the way, was printed in Australia. Hello, David. And during, I think it was 41, this was printed. Yes, 1941. This was printed in Australia. But it's around, it's available, you can find them on eBay. Probably one of the best things you can get your hand on. Go down on the doobly-doo. I have a suggested reading list down there. At any rate, I searched through here, and it didn't specifically have anything on this, but there was a footnote in here about an article in Wireless World of July 1939. It cross-referenced, it said the article name and everything else, and it said it was in the Wireless World. So I went on the doobly-doo and did some searching, and sure enough, came up with this article. And here we are, Regeneration in the Superheterodyne, Wireless World, July 27th, 1939. And I'll be damned, there it is. Now, they're not exactly the same, but this was a real thing. This was done in some receivers. Regeneration in the Superheterodyne. Because I kept looking at this and going, this is a regenerative set. This is regeneration. The weirdness doesn't end here. This is just the beginning. Or I guess we're halfway through the weirdness. So we've got an antenna that goes to ground via, you know, just like an early TRF set. We've got regeneration, like a regenerative receiver going on. We're not using a pentagrid converter. We're using a remote cutoff, or, you know, what else they call it? There's another name for it. Remote cutoff pentode, anyway. This is a pentode, not a pentagrid. 1, 2, 3, 4, 5 elements. Only 3 grids, and typically that's an IF amplifier, and they are using a 66 here as the IF amp. Remote cutoff, super control pentode or remote cutoff pentode. These have a special grid inside where the grid windings, the grid wires, let's make sure we stay in frame here, go up a little bit. The grid wires, you have the 2 posts the grid wires are on, and the center will be very tightly wound, but as you go outside towards the edges, they get further and further apart, so you can amplify very small signals, but as the signal level goes up and up and up, these become less and less effective. That way you don't get a lot of distortion, but you can have a very wide range of input and it'll still amplify it, and that's what they're doing here. And if you really want to understand that and not my stupid explanation, again, pick up the Radiotron Designer's Handbook and you can read all about it yourself. Or RCA tube manuals, take a look at the reading list. Really, it's the way to go. All right, we go through our IF, we move down the line a ways. Then we get here to our, what's sometimes called the second detector or first audio. They're using a 76. Now take a look at that for a minute before I tell you what's wrong with that picture. Anybody see it yet? Okay, I'm going to bring in that other schematic briefly. Here's our detector. Here's our detector. We got a triode, first audio, and what do you have here? You have 2 diodes. Now sometimes these are tied together as they are here, sometimes they're separate, sometimes they run the AVC or automatic volume control separately from the detected audio. In this case they just use them together. This is a very common configuration to just simply tie them together. Well, if we go back and look at our 76 does not have those diodes. So how are they detecting the audio? Well, they're using it as a triode rectifier. And if you look here, you have an extremely high cathode resistance of 150 thousandths and a grid resistor of 2 megohms. Basically, that's a grid leak detector. Just like a simple radio from the dawn of time. Right here, there's your grid leak detector. And typically this was a couple of megohms in the grid. Now this tube was made to be biased at cutoff without a cathode. You know, these were much simpler tubes and they were designed in a special way. But to get the bias so that the tube is running at cutoff, they've got a 150,000 ohm resistor in the cathode side. And why they do that is, here's your IF coming in. You've got your audio envelope here on both sides and your RF envelope here. It goes through that tube that is biased so that it cuts off. It doesn't amplify both parts of the waveform. It doesn't amplify the top and the bottom. It cuts off the bottom, and you end up with this, your audio waveform, which is passed on to your audio amplifier through a blocking resistor, and you have usually a bypass cap. And let's see, here's our bypass cap going to ground to rip the RF off the audio. Here's our coupling cap to our power amplifier, a number 42. This radio is very strange. It's got elements of a TRF set, it's got elements of a regenerative set, it's got elements of a grid leak detector. It's just this is a dog's breakfast of different design things, different design, what's the word I'm looking for? I don't know, my brain's too old. But if you look up, you can look up triode rectifiers and they'll go into a full, you know, there's full explanations online if you really want to look them up. But all this is basically a grid leak detector. The tube is biased so that it cuts off half of the envelope in your IF, and then you pick off the AC in here to your amplifier. This didn't take me long. I looked at that for a couple minutes and I knew what was going on. But what threw me, I'd never seen regeneration in a superhit before, and there it is, just as plain as the nose in your face. So this one was fun. This was a learning curve, or learning, not a learning curve. This was a good chance to learn something. Let's put it that way. I can't think when I'm getting too old. My vocabulary is gone. What threw me initially is I couldn't find these, and I couldn't figure out where it would be because there wasn't enough wires coming out until I really sat down, and it dawned on me that they have tied the grounds together internally, and I only needed 4 wires coming out the bottom of that IF transformer to do this circuit. Very strange. It works well, as you will see later. It actually is a pretty hot little receiver. I was concerned, well, I was very concerned that I was going to have howling and feedback issues because of all these gimmicks that might get disturbed, but these are wound very tightly and enameled right onto the coils, so those didn't get disturbed. This set, however, is extremely sensitive to the shielding, the shields, the tube shields. If they're not properly grounded, this thing does go into howls and oscillations, but as long as your tube shields are grounded, this set works very well. Okay, back to the video itself. Okay, we've pulled that mess out of there, and sure enough, this is one of those wire wound resistors, flex ohm resistors, that's gone open. We have a double 0.02, 0.02 at 400 volts with a center ground, and then this resistor here. Now I'm torn. Do I go with a 3K or do I go with a 4500 ohm 4.5K? Or maybe you just make it a 4K. Maybe I'll just split the difference there and make it a 4K resistor. This is marked 300. I'm assuming they mean 300 ohms. It certainly isn't 3 mega ohms or 300 mega ohms. It's going to be a fairly low value because that's in the cathode circuit. So I'm going to go with a 300 ohm resistor there, non-inductive. Of course, this would be inductive. That's a wire wound. I don't know. I don't know what they had going on. But this was across there, and it looked for all the world like a jumper until it dawned on me it was probably a resistor in there. So I got to change, put 2 new caps, 0.02, 4K resistor, and a 300 ohm resistor in there. So we'll get all that stuffed inside, change the other 2 caps. One here, and we'll have completely recapped and changed resistors in this radio. Now one of those diode looking ones, one of these that's down in here, was spot on, absolutely fine. The rest of them were over double their value. And I'm torn. Do I pull out that original resistor? I really hate to do it, but I don't know, I'll be hanging on to this set. Maybe I'll leave it in there. But we'll change this one out because this is like double. I forget exactly what it measured. Let's see, move the camera. Get over here. That looks like orange, black, red. And we're on 1K. Oh, it's 5K. It's not as bad as I thought. What was I looking at before? That's actually not horrible, especially since it calls for a 4.5K. I think I'm going to go with a 4K resistor. This is marked 3K. It's reading 5K, so it's gone high by 2,000 ohms. We'll put a new resistor in there just so that the values, cathode resistor, is a little bit closer to what it should be. Okay, that's it. I'll see you when I'm finished. Okay, the last of the capacitors are in. We have a brand new line cord sheathed for your protection. Over here we have the gut pile. Everything that got removed and replaced. If these had been originals, I would have restuffed them, but those are replacements. Originally this had one large filter can right down in here, and there's 4 wires coming out of it. The 2 power supply filters and the cathode bypass cap, which is down there. But we'll see if this thing will power up. Now the speaker isn't ready yet. It's still behind me. I've been picking at it, trying to work my way down the split and get the cone back in position, back in shape as close as I can to what it was. However, it will still make noise, although it's going to sound like crap. But at least we'll know if the radio is alive. Variax all the way down. Seat the tubes back in here. I had to pull those up to get them out of the way. Put some of the thermonic FETs back in. 42. There's my two fat pins right there. That's our audio output. This must be the 80. Yes, it is. Two fat pins over here. Our rectifier is in. We've already done a run without the rectifier. We know the power transformer is okay. And here's our 76. This is our grid leak detector, triode. And if everything wakes up, then I'll spend some time polishing up the chassis. Put a coat of paint on the transformer. Something interesting I did find. This transformer is marked 117 volts, 50 cycles. Now this says, unless otherwise marked, it's designed to operate 105, 125, 50, or 60 cycles AC. So I imagine the 50 cycle will run okay at 60 hertz, but a 60 hertz transformer I think would run too warm at 50 hertz because the waveform is slower and it creates more heating. Whoop, there's one more for the gut pile. I believe that's the way it works. I'm not a transformer expert. Far from it. Okay. Let me get the speaker over here. Come to Papa. A toothpick sticking out of it is to hold the two pieces of paper level while the adhesive sets up. I tried using Gorilla Glue contact cement, but it doesn't have enough strength, so I reverted back to my old standby liquid electrical tape, which has a little more body to it. Okay, turn it on. Boy, that wire-on pot feels gritty. Let's turn on the Variac. We're on dim bulb. Again, we know the power transformer is okay. We'll just keep an eye on things as we bring it up here. There's 30 volts. Our pilot lamp is starting to light. I should probably take a look at the B+. The rectifier's fine. There's 50 volts at 170 milliamperes. Now I think with just the tubes, just the heaters, I think we had about 200 milliamps. So we're at 9.4 watts presently. Let's bring it up some more. Typically these things wake up around 80 volts, 90 volts of AC. I'm not hearing anything. Whoop! I'm hearing pops. A little bit of popping and crackling in the speaker. There we go. Okay. Got something going on there. There's no antenna on it, but got activity. Let's go for broke. It's 330, 27 watts. Alright, we've got activity. Looks like we have a winner, folks. And again, I'm not expecting it to sound very good. Okay, I'm going to turn this down a little bit, get rid of the dim bulb. There's 116. Oops, that's too much. 100 and, come on, 120. Come on, down, down, down. There's 122, close enough. Well, I'm gratified to see there's not a lot of squeals and squawks coming out of it. Let me grab a hunk of wire for an antenna and see where it goes from there. Oh, and surprisingly, the grommets holding this thing, they're perfect. Nice and pliable. That was a surprise. Alright, we got about 25 feet of wire strung across the basement here. I haven't had a chance to run an antenna over here yet. We'll get around to that. But looks like the shortwave section works. At least it's picking up noise. And again, I didn't expect much in the way of fidelity out of this speaker because the voice coil is pretty much frozen in place. It's right up against the magnet, so until I can get that squared away. But I don't want to do that until I've repaired the tears in the speaker cone, because as I do that, I'm sure I'll affect the centering again. It's reasonably sensitive. It's picking up 610, which is a fair distance away. I think that's 1250, which is a relatively weak station. Some of my All-American 5s struggle to get that. That's 1370 right just down the street from me, so. Alright, I think we have a winner. Winner, winner, chicken dinner. I am going to continue working on the speaker, and I'm going to clean up the chassis. I'm going to pull off this capacitor, pull off the shield from this IF transformer, and so I can get behind it, clean this shield, and clean up the tuning cap, squirt some black paint here on the transformer, polish up the chassis a little bit, and make it a little more presentable. And then we can start on the cabinet work. But the tuning cap's in good shape, nice and smooth. It isn't scratchy when it turns, which is amazing. I'm very happy. It actually is a lot more sensitive than I thought it was going to be, but I guess that regeneration helps quite a bit. Okay, we'll be back as soon as I've done some work on the chassis and have something else to show you. Probably ought to do a turn around here so you can see what it looks like right now. Let's kill the AC. And gently persuade this guy to come out. Try to keep it balanced. Come on. I don't want to tug on those old wires. There we go. Get that out of my way. Disconnect the antenna here. And that's what it looks like. I probably ought to just take a couple stills right here as we're at it. And one here. Okay. And we'll have something to compare it to after I've cleaned it up a little bit. Okay, we've Got the set up and running.
Of that money to this noble cause.
The speaker centered up nicely. We put a little piece of felt in here to keep garbage out of the voice coil, especially if you're going to work with steel wool. You got to keep this covered up so it doesn't get down in the magnet. We patched the cone up, repaired all the tears in it, and gave it a quick shot of paint just to kind of blend everything in so it doesn't look quite so horrible. Cleaned up the frame a little bit. It's perfectly presentable in front, yeah, looking pretty good. Squirted a little paint on the transformer, cleaned up the tube shields, polished up the caps and the IF cans and the chassis. Now there's some pitting on the chassis, but this thing's 89 years? Is that right? 89 years old? Yeah, 89 years old.
With a safety net, well, it does with burner.
It's earned some pits in the chassis. If this was really rusty, I'd strip it down and, you know, paint it or replate it. But it's only original once.
When a Democrat caught in a scandal, just pick Hunter Biden, Robert Menendez. It's all the
alternative to escalation, a chance to choose restraint. Burner is an American company.
It doesn't like my fluorescent lights very well, but that's all right.
Check out their website, burner.com/.
I'm pretty happy with the way that turned out, and I'm very pleased that it isn't full of squeals and howls. I was worried about it, but it's working beautifully. It's working good as any of the other sets from this era I have. It's just as sensitive. I think my next challenge will be to try and reproduce the dial face right here. Oh, don't get your phone too close to a set when you're working on it. I was trying to track that sound down for about 10 minutes until it dawned on me it was my phone. But anyway, we're going to try to reproduce this dial. All of the graphics pretty much have worn off of it. And we'll put some grill cloth, we'll clean up, scrape down the cabinet, and give it a coat of stain. I fixed all of the loose veneer, and after it's stained and cleared, we'll put the plastic strips back in here, glue those back in, and this one will be done. This is probably going to be my last video for the year. I'm heading out to the Deerfield Flea Market Near Fest this weekend. This is October 23. Unless I find something pretty spectacular, I'm not going to bother making, trying to get another video out. I've got too much to get done. I know I've said that a couple times. Spent most of the day today up at the Capitol building in New Hampshire, trying to get the last of some legal stuff done for my parents. They passed away, believe it or not, 11 years ago. And we're still dealing with stuff. Dealing with government is just so much fun. At any rate, I think I'm going to end this video here for now. I doubt this, I'm not going to get to the cabinet before I go. I'll keep working on this. I can do that while I'm in Thailand working on the graphics and reproducing that. Do it on my laptop while I'm over there. That's it for now. I'm the radio mechanic. So happy that this speaker centered up nicely. Once I moved the spider around, the voice coil didn't drag anymore. I think it looks pretty good for its age. Take care, stay healthy. We'll see you next May. Bye-bye.